Hi, everyone. Good afternoon, evening, whatever time it is for you. Thanks for joining us today. Today, we are on the number 4 of a series called Time to Simplify IoT. If you missed the first ones, I'll share some links after or toward the end where you can catch up on the first episodes. My name is Olivier Bloch. I'm a principal community PM in the Azure IoT team. And you can find me on Twitter at obloch, as well as on YouTube on the IoT show that I'm lucky to host on ak.ms/IoT show. If you want to have some news about what's going on at Microsoft when it comes to IoT, please subscribe to the show, join us, and engage. We have plenty of nice examples, samples, news updates, and so on there. So, time to simplify IoT. So, if you've not seen the first 3 episodes, it was about trying to reword the way we frame and talk about IoT. IoT, by nature, is something that can be perceived as complex. We talk about it as, hey, it's hard, and we are here to simplify IoT. I wanted to take a different angle to this series to actually simplify the way we're talking about IoT, making sure that that it's understood that it's not that complicated at the end of the day. Being technologists, there are tons of notions we need to learn, but it's not that hard. It's not rocket science. Well, we can send rockets in space thanks to IoT, but it's not that hard. Forgot to mention, if you want to ask questions, just like throw the question in. I'll try and track what's going on over here in terms of the questions and answer while I'm talking. And if I miss a question, maybe I'll come back to it later. I'll do what I can. So the series of 4, in terms of simplifying how we talk about IoT, to explain that at the end of the day, it's not that hard, it's not that complex. First episode was about explaining the simple ways you have that exist out there to prototype an IoT solution. Most of the projects are stalling at proof of concept stage, not even when they start development. And they stall because IoT is perceived as complicated. And if you approach it in a complicated way, at the end of the day, yes, it can become really daunting and hard. But there are simple ways for you to prototype a solution and really validate the value add for your solution. Does it make sense to add IoT? Is it something that you really need? What is the value you're going to extract from that? You can build a proof of concept in a matter of hours with actual hardware, with simulators. So this is what this first part was all about. The second part was about the integration of IoT devices into solutions. Once you have validated that you can extract value from IoT, you need to understand how devices are connected and how they will integrate or can integrate into a broader solution. This is what that second episode was about. The third one was about talking of the intelligent edge. We'll talk a bit more about it today as well towards the end. But that talk was about explaining what kind of intelligence you can distribute down onto what type of devices. So I really invite you to go and check them out. Today, we'll talk about the I in IoT, the internet part. And we'll focus mostly on what are the concepts you need to understand if you're not familiar with the cloud, especially if you're an embedded developer. You can be a bit, surprised or in unknown territory here. So we'll try and decipher, simplify the way we're talking about the internet and the cloud, really show you that it's not that much complicated. It's something that is totally reachable, attainable, and that you can leverage and use, or at least start learning about and then start using. So that's IoT. Well, we talked about it already. In a nutshell, IoT is about the value you can extract from connecting things, connecting devices to the cloud to extract insights from the data you ingest, to monitor remotely, to manage remotely, to control remotely. IoT is supposed to bring different types of values depending on the scenarios, and we'll talk about some of the scenarios. One important thing is that the I in IoT, the cloud part at the end of the day, is what we're going to focus on today. Let's consider we have devices connected, like we discussed in that second episode. Let's not focus on how you're going to distribute and control these devices. We'll really focus on what concepts need to be understood and what needs to be done on the cloud side of things. So what are the top scenarios in the industry that are made possible by the addition of cloud? You have lots of scenarios, lots of industries. Here I'm just citing 6 of them, but these are the top ones that we're seeing out there. And at the end of the day, you'll see they're pretty basic, I would say, because the first one is remote monitoring. What you want to do is being able to have a pulse of your infrastructure, of your devices in the field, in the factory, in your city, to be able to monitor many of these devices at the same time, not only to see in what state they are and what health they are, but as well as controlling them. When we say remote monitoring, very often we think about the telemetry that comes upwards, but there's also a way to control these devices. So remote monitoring is definitely one of the main scenarios, with the ambition of gathering the telemetry, the insights that these devices can generate. Lots of these devices actually are running on battery and just sending telemetry, bleeps of telemetry from time to time, plenty enough for lots of scenarios. Asset tracking. This is something that you are familiar with if you order stuff online. You want to see where your devices are, your purchase is, so that's the retail version of that. If you have a fleet of devices out there, you want to track them as well. You want to know where the tools are. You want to know and you want to know who is using them, if that person is authorized to use it, and so forth. So you have a additional level beyond remote monitoring, which is the attach or the connection to a business workflow and business infrastructure to have this asset tracking in place. Fleet management, so moving vehicles, moving stuff that you need to know where they are, whether it's a rental company you have, whether you're in building, in construction, and you want to know and track and optimize the flow and the usage of your fleet. Predictive maintenance is one that is interesting. It adds to an actual scenario of, let's say, devices in a factory floor or something, the ability to analyze in the cloud a huge amount of data from one device, from many devices from one place, from many devices from many places. And thanks to the power of the cloud, almost infinite storage, almost infinite compute, you're able to do analytics that will allow you to create models that will help you predict the state and the health of your devices, of your things, of your environment. And you're now able to enhance the maintenance, enhance your operations, thanks to that prediction that is only possible because now you have the power of the cloud at hand, and to which the devices are connected and with which they're sharing their data and their insights. Precision agriculture is a very interesting one. Lots of places you need to optimize, or you want to optimize based on moisture, based on winds, based on plenty of factors. And so precision agriculture is definitely one of the main scenarios we're seeing. Once again, because of the remote location and nature of agriculture, where you have fields in remote places that are pretty big, having the power of the cloud allows you to harness the data from all these sensors, once again, establish models and implement logic and sharing that information with other farmers, with other industries, other part of your company, and so on. All of that thanks to the cloud. Smart building is another one that goes along with smart cities, where you go even beyond the harnessing of data, the extraction of insights, and the action you can take, because now you can start, thanks to the cloud, you can start to model, you can start to create these models, these ontologies that put together people, places, things, and with these models, you're able to create smart buildings, smart cities. Once again, thanks to the cloud. The cloud and the internet part of IoT makes all these scenarios more powerful, enhanced, and sometimes just possible, things that you could not do before having the cloud in the mix. Let's say cloud, right? Internet, cloud, I'm using these terms interchangeably. So that's the same thing for me in the way I'm talking about it. So what does the cloud enable in this scenario? Why is the cloud helping? What are the things that it makes possible that you could not really do before that? Well, the first one is it brings your operations with IT, with your IT infrastructure. Devices need to be connected, but now you need to go to the next level of integration, of connection. You also need to intermix and put in relationship the workflows, your operations workflows. Let's say the deployment of a new set of sensors with their provisioning, their installation, and so on. You need to synchronize that with your workforce and the actual process you need to stop to deploy these new devices, these new sensors. Maintenance, same thing. So you have this notion of getting together, putting together operations and IT. And this is something that is common to most of these scenarios I just described here. And that is made possible thanks to the cloud. Storage and analytics are ready, and we talked more about that today. Well, now you have lots of storage available because it's like big data centers. At the end of the day, the cloud, what is it, right? It's a set of data centers that run services, allow you to store data on, and deal with redundancy, availability, and so on in various shapes and forms. And at the end of the day, you could not have that much storage and that much compute. Well, that's not true. You could, on premises, you could set up a set of servers fine-tuned for your own needs in terms of the amount of storage you need, in terms of the analytics. But you save a lot by not having to deploy and maintain your own infrastructures to implement the same level of storage, same level of compute. So this is something that the cloud brings to your scenarios that you could not really afford, I would say, before. Or that would not be a good ROI for you. Now it's available through big cloud providers, and so you can think of these new kind of scenarios made possible by cloud technologies. Data visualization, whether it's in real time, whether it's time series that you're going to investigate, looking in the past, and a huge amount of data has been stored. The extraction of insightful information thanks to models and machine learning and others implemented in the cloud through the analytics we just mentioned and talked about, it's something that gives you a new vision, a new visibility into your data. Something that doesn't require having experts all the time around. The experts can work on models, can work on software that will extract the insights, and then the insight can be delivered to the right people who can now take action. I'm not even talking about automation of processes, because that's definitely something that you want and will do thanks to the cloud and thanks to the power it adds to your applications. Last but not least, the integration. Well, that's for that slide because I have more after, but integration into business workflows. I mentioned the example of predictive maintenance. That's a good one here. How do you make sure that, if a device reports that tomorrow it's going to fail, or that it needs to have some parts replaced or updated or whatever, how do you synchronize that with your workforce? How do you make sure that you have someone available on that date at that place? Eventually, how can you optimize that maintenance? How can you make sure that if I have a maintenance personnel that is close by today, maybe I can reroute them so that they don't have to do the trip tomorrow, because I know that tomorrow this will be required. So you can start optimizing, not only integrating, but also optimizing your workflows and the way they are combined. And that happens in the cloud because your apps for business are there already. Now you're adding the IoT to it, where you can control, where you can monitor, and all of that now mixed in the cloud gives you that power. So what other kind of scenarios that you might not think about that are possible? Well, now you have machine learning at hand. You have very powerful compute, and you have a bunch of services that will make your use of machine learning easy. Or easier, I would say. Like a good example of that is anomaly detection. There are algorithms that have been developed by data scientists and software engineers that allow to detect anomalies on a stream of data, that a huge amount of data, and that you don't need to reinvent the wheel for. You can detect that you have an anomaly in your images that you capture on, let's say a mounting belt where you see devices passing by and you do quality check. Well, now you have anomaly detection algorithm you can implement and apply on the images that are captured there, on the various sensors. Maybe you will send a telemetry for vibration on that conveyor belt. And if you see that there's an anomaly that is detected by these machine learning algorithm, you will be able to take action. Machine learning will allow you to analyze a huge amount of data, detect trends that might not be visible at a human eye. And that's something that is invaluable and that the cloud only enables today. Once again, I might be saying things that are obvious, but this is all about the talk, showing that IoT is not that complex. It's common sense. It's about obvious scenarios. And here's the next one: deal with the scale of IoT. Deal with the fact that you have a lot of potential devices you could connect. You can now, and it can be remote, and they can have different types of protocols that they can talk about. We talked about that in that second episode of the series. And then the cloud allows you to deal with not only the volumes of data and devices, but also with the diversity of them, the fact that they're talking different languages, they're sharing the data in different formats, but also the fact that your solutions in real life will be about different kind of customers, different locations, different tenants for the application and services you will deliver. The cloud makes that easier, makes that possible. You don't have to reinvent, once again, the wheel or to develop the plumbing. This is taken care of by the likes of Microsoft, Amazon, Google when it comes to cloud solutions and platform. Another scenario that is enabled by the cloud is simulation. With the huge amount of data you can now analyze, you can simulate more easily. You can simulate conditions. You can combine with machine learning, create the models, and you can verify hypotheses. You can verify that a system will support a spike in usage, a spike in some of the data that can become extreme or whatnot. You can test things in a virtual environment in a way that you couldn't before. Before you could do, conjectures and then eventually try in real life and risk breaking everything, risk wasting lots of money. Well, thanks to the cloud now, you can implement very rich simulations. And there's tons of companies who are providing simulation environment hosted in the cloud to make it even easier for you when you implement a solution. Last but not least, and we'll spend some time discussing that towards the end of this talk today, digital twins. So once you have the data available in the cloud, once you have machine learning algorithms and you are able to create models, well, you can now create a digital representation of your things, species, people, and create models of that. That's what we call a digital twins. I'll go into details there, but that's only possible since the cloud is in the mix again. So these are all the scenarios, all the capabilities that the cloud is bringing to existing solutions for you to extract value, for you to enhance your processes, for you to go through that digital transformation. I know these are all big words, but once again, all of these scenarios that we could only dream of a few years ago, they're now here. They're now possible. And that's what IoT is about. So I hope I'm not losing you, but let's actually break it down. Let's break what that means and how the cloud shapes and how you will use it, how you will implement your solutions. At the end of the day, if you look at this diagram here of IoT, where devices are connected through gateway directly to the cloud, where in the cloud we are extracting insights, monitoring, controlling the devices, integrating to business applications. We mentioned that, we talked about that. That's the value of IoT. At the end of the day, if I want to simplify that a little, devices are connected through a device gateway. Once again, referring to episode number 2 of the series here, that connectivity, let's say it's a given. You have this notion of a device gateway in the cloud. That's basically the service, the entity that will deal with the authentication, that will make sure that there is a bidirectional communication channel in place, and that now you can interact from an application in the cloud. When I say an application, and we'll see that, it could be different types of things. But think of it just as an application. That's something running somewhere that is a combination of pieces of software and that allows to implement the functionality. The functionality is to interact with the device gateway first to deal with the devices themselves, communicate with them, and so on. But it gives you a higher level of abstraction than the device gateway, which is kind of raw. Think of it as your basic plumbing down there. The cloud application implements the functionality, and that's what you will be developing in the cloud, leveraging different types of services. There's also storage. We mentioned that, and we'll see how that works and how what kind of storage you have, and take advantage of. So that's, at the end of the day, how the application that now integrates IoT will work and act. And now your operators can interact with the application, get insights on the devices, control them through that cloud application and whatever clients you have for that cloud application. As a matter of fact, you can also have them wear devices that will give them insights into the data of the other devices and so on. So that's where operators will interact with your application. And then your business aspect of things, well, that business entities will interact with the cloud application. When I say business, could be customers, could be your business employees or customers. There's that interaction through that cloud application, and eventually through the data that is stored in the cloud, a huge amount of data that can now be visualized, that can be analyzed, and so on. In a nutshell, that's what it is. The internet in Internet of Things is as simple as that. A cloud application that is a combination of, as we'll see, set of services, API, software, whatnot, that actually follows some simple rules, and we'll talk about some of them. So these applications are all about data and the journey of that data. IoT applications like all the other ones at the end of the day. So there's nothing new there. So what kind of data analytics to start with? I'm not talking about storage yet. We'll talk a bit about that, but storage is storage, right? You have different types of storage: structured, unstructured, fast accessible, not whatever. Not the point right now. I'm sure you know all of that. We are leveraging all of that. But the context of IoT application, I think there are notions that are really important when it comes to data analytics that needs to be understood. And then there's going to be another one about storage that will come up. In terms of analytics, I do believe, and if you disagree, you should come up here, but there are two main types of analytics. And this is important because this is where you are extracting the insights and the value from the IoT data. There is a near real-time analytics, things that will allow you to do analytics on streaming data flow that comes up, and you will be able to look at that and implement sometimes some rich machine learning models that have to be trained and optimized to react fast. Because very often when we say near real time, that means you need to take action. We'll look at that. We're trying to push that to the edge when possible. And there are different scenarios for that. This is the episode 3 of the theory, the one from a couple of weeks ago, that I really invite you to look into. And very often for this near real-time analytics, what we're going to use is services that do stream analytics or designed for that, or that are serverless, things that will be triggered on an event. We'll be able to do some processing, do some recording, and take some action. Things that are running like, in an event way, not some things that are actually in the back end waiting for a bunch of data that's something different, right? So near real-time analytics is key for IoT because it gives you that automation capability, as well as fast reaction, as well as optimization and reduction of costs and so on. So that's a very important type of analytics that is not really new, but is more common in IoT scenarios than in other types of scenarios. The historical analytics, compared to the near real time, is about storing a huge amount of data for longer term or deeper analytics. Imagine you're capturing your vibration sensor telemetry data from a conveyor belt, once again in your factory floor, because you want to see if this vibration shows any sort of trends. Are some bearings starting to wearing out? Is there any potential that the thing's going to fail? Eventually, if something failed, you can look back at a huge amount of data, and thanks to very rich machine learning algorithms you can develop in the cloud, you're not able to identify what went wrong. And retrain your models that will do the near real-time analytics to predict better, to analyze better what's going on in near real time, so that you can optimize and you can enhance safety, you can enhance your production. So historical analytics is key, very important, really different from the near real-time analytics. These are the two categories, I would say, of analytics. We'll see how they shape in an actual short demo that I have after. But these are really important concepts to understand and to be familiar with. And there are tons of services out there. I'm not going to list them or say names or whatnot. But there's tons of services specialized in one or the other. These services help you implement different types of journey for your data. The data comes from devices, goes all the way up to the device gateway, then lands into the cloud application or storage or both. But there are types of transitions for that data. We talked a bit about that, but the way devices are connected, the fact that these connections might be a bit flaky, not permanent, or expensive, are things that will push you to not having to rely too much on that real-time telemetry data, and push analytics down to the edge. But if I were to simplify things once again here are the type of journeys your data will take, assuming that you already sorted out the problems of, where is the data analyzed and so on. I will here, for the sake of this diagram, talk about the basic scenario and the common scenario. So these devices are connected. You want to extract insights instantly. That's the near real-time analytics part of it. And for that, we'll implement something called a hot pass. The data is hot, data is coming, you do a quick analytics on that, and then you take action. And very often there's a bunch of things you can do at the device gateway level side of things, or just above it, where you can set up rules for routing your data based on parameters, based on telemetry values, based on states of these devices. So that hot pass requires data to be streamed and to be analyzed in that streaming mode. Then there is a warm pass. The warm pass is when you'll go through some form of storage, some form of smaller analytics applied to a small batch of data. So you can do this kind of operations on a little bit more of data. If you want to analyze a trend, for example, for anomaly detection, might not be instant on one telemetry. You need to actually do a batch on the last 2 minutes, for example. And for that, you need to have a type of storage that is rapidly accessible. The data comes in, goes into that little storage, and then you can have your fast analytics interact with that data service and extract data rapidly from it to analyze it and to take an action. When I say rapidly, it's all at the cloud scale, and that's what we call that a warm path. So really think of it as the intermediary between the hot pass and what is called now the cold pass. Cold pass being, I want to store a bunch of things, not costing me too much. So you need to have a technology in the cloud that will allow you to store for not much, but caveat is that data might not be instantly available. But it doesn't matter for lots of scenarios where you can have long-running, very rich algorithm trained and then operating on a huge amount of data that is stored in that cold path. So now you can see these three types, and there's all the variations in between, obviously, of data journeys. Data that stays hot, that you need to analyze immediately. Data that needs to be batched so that you can do some more in-depth analytics, but still something that needs reaction, needs something that at a human level is interactive. And then the cold one, which is related to very often the amount of data that you will be able to analyze thanks to the cloud. You need to understand that, because at the end of the day, you have different considerations for the services you're going to use to ingest the data, to store the data, to analyze the data. Different types of services available out there, and sometimes you might be confused when you look at the options in the cloud. In terms of Should I go with the serverless function to analyze that piece of data? Should I use Stream Analytics? Should I just have data going to a blob storage and then have my application running, as a microservice that I develop myself, do its work on that blob storage? So you have, or a data lake or whatnot. So you have all these options. Try and approach them from the perspective of that set of data needs to be analyzed in a hot pathway. That's the journey for that kind of data. That data is more for a warm path. That data is more for a cold path. So think about it this way. That will help you rationalize and simplify your choices when it comes to the services you're going to use in the backend. So now you have understood the types of analytics, the types of data path, right? Because everything revolves around the data, as I mentioned earlier on. How will you build an application? That bucket that does the insight, the visualization, the monitoring, and so on. You have different options. I'm not going to demo everything here. I'm going to mention and talk about them at a high level. I have a short demo that illustrates hot pass, cold pass, and so on just after using Azure IoT Central, just to illustrate the point. But here, what I want is to list the options. We're talking about software. At the end of the day, you can do everything from do everything yourself, all the way up to leverage existing SaaS applications, solutions already developed and provided as a service for you, so that you don't have to code anything. You just have to sign up for a service and it just works for you. So that's as simple as that. If you want to host your application, all the cloud providers have infrastructure as a service. You'll host a virtual machine, you'll host a container, and you'll be able to run the software of your creation in there that does whatever you want, right? So you can, from there, interact with your devices, you can do your analytics, you can do whatever you want. Another option is to start using bricks of Legos that are available for you, as services that are specialized. A service for storing, a storage that will go fast, a storage that will be cheap but will be slower, an analytics service that will analyze in your real-time streams of data, a function that will be able to trigger some code that you will be developing without having to care about the infrastructure that is behind it. Do I need to host a VM? No, you can use PaaS services for that. You can use web apps and device client apps for the front end as well, using PaaS services. It's something that allows you to leverage plumbing, sometimes more than just plumbing, that is available for you, and that you can connect these things together. You can have services talking to each other in different ways, in an eventing way. You can have pub/sub infrastructure in place to have these services communicate. You can, all sorts of things you can do with these PaaS services. What that saves you is the time of reinventing the wheel and developing the functionality of each of them. Obviously, sometimes you don't need such rich services, and you can go along with just a piece of code of yours that does the minimal thing that you need. But very often, you will be able to enhance your solutions and your applications thanks to these PaaS services. There is a next step as well, which is the SaaS solutions. Solutions that are turnkey, that offer something that is already pre-baked in terms of an interface, in terms of visualization, and so on. Our partners are delivering these kind of solutions for special verticals, sometimes paired with devices. So you can just go shop. You want to do asset tracking or fleet management? Chances are there are solutions out there. You can just subscribe to these services and just use them, versus redeveloping everything yourself. And when you're looking at a proof of concept for an IoT solution, you need to think about it. Do I need to redevelop everything? Or is there a solution that maybe upfront will cost me a bit more or less, in the long run, way less than having to develop everything myself? Sometimes you will be like, no, I'm going to develop everything myself. Yes, higher cost upfront, but then in the long run, it's going to be way more efficient for me to maintain. But don't leave any options out. You have these SaaS solutions out there. I'm going to use one in the form of Azure IoT Central in a minute that gives me not just the building blocks, but also UI and so on. So you'll see it's pretty interesting. And you can also go beyond that with services that will deliver codeless or low code functionalities for you to build your application. Power Apps is something that starts interacting better and better with IoT services, SaaS or PaaS services, and you can start building application that will allow you to visualize data, to interact with devices in a very simple way. So I really invite you to check out building applications, companion app for your devices, for your solutions, leveraging Power Apps, leveraging serverless, and so on. So that's something that is a trend in many industries, low code, no code. That's valuable as well and valid as well for IoT scenarios. Okay, so enough talking, little demo. There's no IoT talk without a demo. Where's devices? So let me do one thing for you here. I'm going to bring up, oops, screen. I'm going to bring this guy here. Going to be my screen. And, oh, there you go. So I can keep a track on the comments down there. I have an IoT Central application. You've seen it. That application is actually getting data from a little tiny device that I have here, which is an M5 stack dev board. It is sending its telemetry, sending also a motion detector event to my IoT Central application. I'm not going to go into details here because I described all of that during the first session. Building my, I don't remember what I made up at this time, but it was, your own cheese cave or one cave or place you need to monitor temperature and humidity from a device. I showed you how with no code you can build a prototype to deliver value on that. So here I want to illustrate the notions of hot pass, cold pass, warm pass, this kind of things. And I'm leveraging IoT Central. I could have done that with other services, other solutions. IoT Central gives me something that I could for, so it's pretty practical. I like that. So here I'm visualizing real-time data. It's actually it's not real time. It's I would say almost warm pass in between hot and warm. Data is refreshed on that UI every few seconds and might be a few seconds behind. Let's say, for example, here I'm gonna wave my hand. It's gonna detect the movement, and you'll see in a few seconds that pop up over here. So now if I want to take an action on that data, I want to trigger an action when something happens, for example, how can I go about it in a simple way? Right, so I have this notion of telemetry data coming in. It has a format. I understand it. Here I'm using a functionality in my SaaS application, which allows me to set up rules. So I did set up rules for something called device needs maintenance. When I press a button down there, it's going to send a specific telemetry data point. And so on that specific device, I set a condition. If that condition, which is the telemetry called needs maintenance, is set to true, then I'm going to trigger an action. And here we're leveraging serverless. We're leveraging a Logic Apps. Logic Apps being a service on Azure, it allows you to connect applications in a codeless way. Actually, let me show you how that looks like. Let me open this little guy in the portal. I'm going to bring up that page. It's loading. Oops, bad. Mini screen. Okay, that's the guy. So the Logic app that I was sent to directly from the IoT Central application, if I look at the code in there, it's pretty straightforward. Once again, when I'm going to press the button, it's going to fire this rule. And when this rule is fired, and I use a connector into Logic App to do something, I want to post a message on Teams. And this is to illustrate that hot pass that will integrate, in the workflow between operations and the IoT applications. And here, what I want to do is notify someone that this device needs maintenance. And that's pretty straightforward here, but you can definitely implement much richer scenarios. You can invoke webhooks. You can do things that are way more powerful than that. And here, I'm going to just do it real quick. I'm going to press on the little button down there. The thing says that I'm going to need to do some maintenance on that device. In IoT Central, I'm going to receive the note. And here, if I look and bring up the flow, the Power Automate flow here, you see 9:40 just now, I received that notification. This other one was for test before. That is saying that my device, my 5Go, needs the maintenance. So you see it was like almost instant, press the button, receive the message, pretty straightforward. If I want to show you another one here, that is kind of fun as well. I can add some conditions on that. And once again, you'll see it's nothing magic. It's a motion detected. There's that sensor on that device. I'm putting a condition when the property R for red, for the red LED here, is 254. I'm going to trigger an action when the movement is detected that will call a webhook. Now, webhook, it's just a webhook, pretty straightforward URL with some authentication code in there. And this one is about setting lights to pink. You see, I've got lights behind me. So hopefully, if I do things correctly, which is setting that value to 254 for the M5Go device, let me go there. I'm going to go to properties. I'm going to change this little guy here. 254. I'm going to see it change to a different color here. You can see the red appeared. I'm going to move my hand in front of it. It should be detecting the movement. And once the thing is triggered, boom, you see lights turn to pink behind me. So I was able to really rapidly, and I could have done it live. I would have wasted 5 minutes, but it's pretty straightforward to do it. If I want to change it, I can also go and change that rule. Let's say motion detected. I want to say if R equals, let's say 255, G equals, let's say 255 as well. And you might see where I'm going with that one. B equals 255. Once again, we have all these conditions. I'm gonna call a webhook here. And that webhook, actually, I'm gonna call a different interface for my if this and that service. I will be setting the lights to, it's called pink, it doesn't matter, to white. And now I'm setting that rules. If I change the colors of my lights back to, let's say, blue, I go, they're blue now. And now if I move in there, nothing will happen because the color is not right? So my color was still blue, right? And if I go and change the properties on my device, oh, actually it did trigger. I didn't save my rule. My bad. Okay, bad example. Let's go back. I messed something up. That's real life demos. So device template, all the conditions are true. They should be all to 255. And they were not. Things still triggered. Might not have saved that thing correctly. In a nutshell, you get what's going on here. This time it should work better. I need to set up the properties to the right values, and then it will trigger only if they are valid. Anyways, you get the point. I changed the color, so it went to green. I'm shaking the thing in front of it, and things will happen if they need to. Here, they don't, because the properties are not in the right set value. And I save now this new value here. This device turns to white. I wave in front of it. And now the rule will be triggered because the conditions for the properties are set correctly. So that's something, and the light will turn white at some point, right? Some magic. There you go. Did it. So that's an illustration of the hot pass, something that you want to interact with that device instantly, and you want, or actually you want to have the data trigger some action as it flows, as it's streamed through, so that you can take action. But now there's that notion of hot pass or cold pass, sorry, that I want to analyze a huge amount of data from the past to extract some insights. And there's tons of services there. Here I'm going to leverage some storage that is set up behind. I've been exporting data from my IoT Central application. If you look at the settings here, what you can do is set up different types of destinations for your data. I have a blob storage and I have an event hub thing. So here in blob storage, what I've been doing is sending all the telemetry into storage. And that was done as simple as create a blob service and then set a destination here in my application. And now I'm able to visualize that data. So if I go to my Azure Storage Explorer, here I have a container that if I look into it, let me refresh that to make sure I have fresh data. Let me go up. I've been digging into that. So IoT Central will push data to that storage container. We'll put that in the form of folders by year, by months, by day, which is 20s today, by hours is GMT. And if I look, we are what? It's 9:45 a.m. here. That's the 1 minute ago. And I look at that data, I'm going to download this blob, and in there, I should see the telemetry from my device that has been created just a second ago. So it's transferring the data. And you see here, it's pretty slow because my client is not that fast. Let me open this blurb with Edge, and you see here, I have the piece of data that's been stored in storage. In there, there's a bunch of things, bunch of information that I can now extract from the cold pass storage into my reach service that will do reach analytics and so on. So you see it's pretty rich and pretty interesting because now you have every single detail, everything that happened. Another way you can visualize that is by using time series service. Time series insights is a good example of this kind of service. You want to go back in time, you want to analyze by timestamps. This is something that when you talk about telemetry is very common. So here I set up in IoT Central a view to do some analytics on the M5 Go devices, temperature, humidity, movement detected, all of that. I will analyze and it will visualize all of that. And see here you have a timeline, there's a retention, certain number of days. I want to see what happened. You remember we had a heat wave. I want to check out the temperature and so on at that time in the past. So I'm able to go in there and visualize the temperature we got. We went all the way up to 40, almost 40 Celsius over here, which is like pretty hot for the region. And I can go into more details and I can correlate that with motion. So here I've been putting my device out and in to measure, or actually not in and out, but different locations around my house. It was always out there to not have it directly exposed to the sun, to really measure the temperature. That was a real life temperature. And here I can see a correlation between the movement detected, which was certainly, when we were in front of the device, right? Someone was moving in front of it. And here you can see device was certainly in a cooler space. Maybe that's at night, actually. And at night, nothing happened, right? So yes, it was at night. You see 3 a.m., 2 a.m., whatever. But I can now see the correlation for events that happened in the past. I can even go into more details because that's pretty rich in terms of the details here. For my data, I can see all the movement that happened and correlate with my humidity and temperature. I do that as a human looking at that, but obviously I could be doing that with some algorithms. So that's that illustration of the cold pass and the power it can have. I just saw a question, can I extract from Raghavendra, can I extract JSON payloads from IoT Central directly into Data Lake Gen 2? You can push the data to a blob, and that's the way you're pushing data to Azure Data Lake. And the JSON payload itself is structured whether, actually it's IoT Central, so it's going to be structured as a plug-and-play payload. So you can, with the model, extract that in your applications on the back end. I don't know the details about how you can model and use the model from the plug and play model of the device that is in IoT Central to extract the data. I'm not a data lake guy, so I would have to double check on that. So I don't have the answer to that. I bet, but definitely something we can follow up on for sure. That's interesting. I'm sure you can do some level of extraction that is automated by having the model of the data and how it's formatted and extract it on the other side. That's we do that with time series insights, where you can, in time series insights, see the model based on the plug and play model of the device. So that's the way you would do that. Okay, so that was for the little demo about the types of data journeys. Let me go back to my slides because I want to talk about something which is very interesting as well, which is uh, digital twins. And why is digital twins important and interesting? Well, let's chat about it. I used to have I have all these slides that were like super simplistic, super simple to understand. Here I have futuristic ones because digital twins is perceived as something of the future and has these very fancy slides I stole to my CVP that he presented at Build. But that's a very good illustration of what digital twins are about and how the cloud and the internet side of things make scenarios possible. So solutions are built of intelligent edge and intelligent cloud. Intelligent edge being these devices that now run software, are connected, can do a bunch of things. Refer to episodes 1 to 3 of the series. The intelligent cloud that we're talking about today is very rich, thanks to the amount of compute storage that it allows, as well as all the richness of all the services for transitioning data, hot cold paths, for storing it, for analyzing it, and so on. These allow you to create digital models of your environment, of your things, your people, your spaces. You can create that digital representation. It's called a digital twin. Once you have this digital twin, that establishes relationship between the things, these people, these places, and is synchronized with the physical environment. Now you have this view and this way of interacting with your real world through its digital representation that really changes the game. And it is simple at the end of the day. It is a set of services. It is data that is stored. It is rich analytics that will allow you to extract things. Digital twins, the richness in it, the smart aspect of it, is to allow you to have a way to define a model that puts in relationship different entities. You have a device, you have a room, you have a building, you have a person. The device is in a room, the room is on a floor in a building, the person is moving around and at that moment is in the room. So you have a relationship that is defined in the model. Once you're able to synchronize things to IoT plumbing, the data between the real physical environment and the digital environment, you're now enabling a bunch of scenarios. One of them is a new way to monitor your data. We say that remote monitoring was one of the main scenarios for IoT, and the way cloud was helping making it available. Digital twins is bringing that to the next level. The monitoring integrates now the relationships. The way you're going to be able to monitor your assets, your people, your spaces, is going to be simplified both for the human, but also for the software, because now you have a graph that allows you to navigate that unstructured data that is coming from all these various sources in a simple and efficient way. Another type of thing you can do in a more rich way, thanks to, once again, these relationships, is track the past. So you've seen me navigating through the past of a temperature, humidity, and motion sensor information. How about doing that at a scale of an IoT project with hundreds of sensors, with tens of locations, and all of that, navigating that fast to extract the insights you need. So that's one thing that the digital twins will allow you to do even better. Once you have the digital representation of your spaces, once you have your twins, you can do that more easily. The analytics is a given as well, as an obvious one, where you can do rich analytics on this now not still unstructured, but easily navigated through the graph set of data. The prediction is also enhanced, but this is a functionality of the cloud that you already had. Simulation, same thing. Remember, I was mentioning the various scenarios already as what the cloud brings. Digital twins is something that you can apply the exact same things thanks to the cloud to a digital representation of your environment. And now you can enhance the simulation and you can implement a better autonomous behavior and control of these physical environment, because you've tested everything in the cloud, in a digital environment, in a digital representation of your space and people and things. And now you can deploy the algorithms you developed in that digital environment into the physical one. This is what the physical and digital environments mixed together will give you. Last but not least, the interaction. The users now can interact with data in context. I love the scenario of that person which is was roaming a factory floor and is looking through his HoloLens piece at a robot arm, and now you can over impress the real-time data from the device, from the robot arm, onto that robot arm. 5 years ago, we were showing that as a vision, as an aspiration, as something that would be available in the future. Today, all the bits and pieces are available for making that happen. And you don't have much to develop for that. But sure to have some samples for you to demonstrate all of that. This is something that definitely is new ways of interacting, new ways of empowering your workforce, of enhancing your business, and going through that digital transformation of yours. That's what digital twins is about, and it's possible and enabled thanks to the cloud. And now here's a futuristic word. What you're building when you're using digital twins, when you're using IoT, is you're building a metaverse. I love this word. It sounds like it's coming out of a comics book or movie, but it is what it is. You're actually putting a digital world and a physical environment in sync. And now you can interact with both. You can visualize through the digital one, the real one, and you can control the real one through the digital one, and so on. This is a metaverse. This is what you get with digital twins, with the power of the cloud, with the I in IoT. That's the point of this whole thing. I hope I've not scared you with too much information. I wanted to really approach things in a simpler way. IoT is about connecting devices, extracting insights, giving you tools that allow you to improve your processes, add value to your solutions. All the services that come on top, what come in the IoT offers, are here to help you do that. Once you understand what you need to do, to prototype, to connect and integrate the devices into a solution, to make that edge more intelligent, and how to build that internet, that cloud side of things, putting services together, that's really what you need to know and understand. And the concepts that build IoT, that at the end of the day are not that hard and that complicated. I invite you to go and watch these 4 episodes on demand. You can find that on aka.ms/reactor/simplify IoT series. Just bringing that link right now. And also during the month of July, and that will be available on demand as well after, is a bunch of content that our cloud advocate teams are putting together for you. So it's called July IoT. I like the smart name for that one, aka.ms/July IoT. And this is where you can find lots of demos, samples, articles about IoT, and hopefully will help you get started on your journey, understanding IoT. Hopefully, I was able to simplify it to a certain extent, at least in the way I'm talking about it, and that we should be talking about it. And I hope to see you for more episodes on the Reactor in the future, as well as on the IoT show, on the July IoT content, and so on. I'll thank you all. If you have any questions, I'll stay around. Otherwise, I wish you a good day, good evening, good night, wherever you are. Have a good one. I'm looking at the questions. Yep. So we had this one from Raghavendra about extracting JSON payloads directly into data lake, and that's something that that I was saying I'm not able to answer 100%. My hunch is that yes, you can, and you have a model that is the plug and play model that will allow you to do that. If you have further questions, don't hesitate to ping me on Twitter, and you can also find me on my blog, olivierblog.com. Shameless plug, sorry for that. So don't hesitate to ping me there. I'll be more than happy to answer your question. Raghavendra saying, hey, currently we have an IoT use case of using IoT Central to Blob, to ADF, to move to ADSL2, to Power BI. Well, that sounds to be a nice and sound way of doing, but you might be able to go more straightforward from Central to Blob to DSL. So ping me if you want on Twitter, and you can send me a DM or use oblock@microsoft.com. I'll be more than happy to try and help you on this one, Raghavendra. So thanks for the question, or I couldn't answer live. Okay, everyone. Well, I think that was pretty much it. Thank you for your time. I hope you have a good one. See you soon. Bye-bye.